Hi everyone, welcome to Orgo Essentials, not your basic organic chemistry tutorial, episode 11. In this episode, we'll practice naming compounds with functional groups, from double bonds to carbonyl groups. Let's get started. First, let's go over some problems with basic alkanes, just like we did in the last video, except this time, we're going to start with the name and see if we can draw a molecule from it. Let's start off simple, butane. First, we know from the root ane that there will be nothing but hydrogen and carbon atoms, like with all alkanes. Secondly, we know that there will be no substituents, because there's no number or prefix in the name. So, all we have to do is figure out how many carbon atoms there will be, then draw in the hydrogen atoms that must accompany them. The beginning of the name, but, tells us that there are 4 carbons. Remember, monkeys eat purple bananas. Now, we have all the information we need. We can draw our molecule just like this. Next, let's try something a little more challenging. 5-ethyl-2,3-dimethylhexane. This one looks a bit more complicated, but we can apply the same process. Again, the root ane lets us know there will only be hydrogen and carbon atoms. We also know there will be 6 carbons in the main carbon chain, because of the prefix hex. We can go ahead and draw that chain. Now, all that's left to do is to draw the substituents. To do this, we have to number the carbons in that hexane chain, like this. Now, we just go through the name and add our substituents. 5-ethyl means that there will be an ethyl group, 2 carbons and their hydrogens, on the 5th carbon, here. 2,3-dimethyl means there will be 2 methyl groups, one on the 2nd carbon, here, and the other on the 3rd carbon, here. And we're done. Great! We've clearly mastered basic alkanes, with no functional groups. Now, let's see if we can tackle functional groups, alkenes, and alkynes. Here is a chart with all the functional groups we covered, plus their suffixes. I'll keep this chart up as we work through some practice problems. First, let's name this compound. We're going to use the same exact process as before. Step 1 is to find the longest carbon chain. In this molecule, that's easy. It goes from this carbon on the left all the way to the carbon on the right. There are 3 carbon atoms in this molecule, so using our handy mnemonic, monkeys eat purple bananas, we know that the root name will be prop. Easy. The second step is to figure out the type of molecule. We know this isn't an alkane, because there are atoms other than carbon and hydrogen, but there are only single bonds, so we know there will be an an, not ene, to denote double bonds, or ine to denote triple bonds. What functional group is OH? Feel free to pause this video if you want to figure it out on your own. OH is a hydroxy group, making this an alcohol. If we consult our handy chart, we see that alcohols have the suffix -al. We have almost all the pieces of the puzzle, prop, an, and -al, but we need some number to indicate just where that functional group is. Fortunately, this part is easy. No matter how we number these carbon atoms, that hydroxy group branches off the 2nd carbon. Our number will go right next to the -al. The numbers indicate where the functional group is, so that's where they go. Propan 2-al. We did it! Note that this molecule may also be referred to as 2-propanol or isopropyl alcohol. Here is our next compound to name. This drawing might seem a little hard to understand at first. It's what's called a line structure. In this type of model, every intersection or end is a carbon atom. So, there's actually carbon atoms with their hydrogen atoms here, 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 and here. Let's go through our steps. When we count the longest carbon chain, we see 5 carbon atoms. This means that the molecule will have the root name pent. Next, we have to find out the type of molecule. First, we can see that there's a double bond near the center. not part of a larger functional group. This means that, instead of an, our root name will have ene. But a double bond isn't the only functional group present here. There's a carboxyl group on the right end. If we look at our chart, we see that molecules with carboxyl groups are called carboxylic acids and receive the suffix oic acid. Now, all we have to do is assign each group a number. Let's look at the two options for numbering our carbons. First, there's this way, where number 1 is that carbon on the left. This means that the double bond will get the number 3. Functional groups like double and triple bonds always get the lowest number they're attached to. Next, there's this way of numbering the carbons. In this case, the double bond will get 2. These numbers are way lower, so this is the correct way. 2-ene. Let's put everything together. Pent, 2-ene, and oic acid. Pent-2-enoic acid. Perfect. Our final problem for this video will be naming this molecule. Let's start off like usual. Remember that each intersection represents a carbon atom, so there are 3 carbon atoms. This means our root name will be prop. Next, we figure out the type of molecule. There are no double or triple bonds, so there will be an "and" somewhere in the name. But there are 2 functional groups, a hydroxy and amino. How are we supposed to determine what type of molecule this is? Which one determines the type of molecule, and which one is just a substituent? Let's consult our handy-dandy online resources and find a priority list of functional groups. Here, we can see that hydroxy groups, alcohols, take priority over amino groups, amines. This means that our molecule name will end with the alcohol suffix, -al, while the amine suffix, amino, will go before the root name. Now, we just need numbers for these groups. This first carbon on the left has no functional group, while the one on the right does. So it's pretty clear that we have to start here when counting to get the lowest numbers on our functional groups. When we number our carbons like this, we get a 1 on the amino group and a 2 on the hydroxy. We don't need a number for that methyl on the end because it's part of the main carbon chain. It's not branched off. Let's put all our puzzle pieces together. We have prop, an, amino, remember that the 1 goes away, and 2-al. When we arrange these in the correct order, we get aminopropane-2-al. This molecule may also be called 1-aminopropane-2-al or amino-2-propane-2-al. All of these options are acceptable. We did it! At this point, you may still be struggling with organic nomenclature. That's okay. This is probably one of the hardest things to understand in all of organic chemistry, simply because there's no other chemistry or science topics like it. However, I've personally found that it helps if I think of orgo nomenclature like learning a new language. Other metaphors that may do you well include putting together a puzzle or decoding a message. I hope these help. That's it for this video. As usual, I've included a document with some nomenclature practice problems. Remember, practice makes better. If you have any questions so far, feel free to email me or comment down below. The next video will be about some miscellaneous concepts in nomenclature. I'll see you then!